Some scientific ideas have their moment, and then, poof, they're gone. But every once in a while, an idea comes along that just refuses to die. Today, we're talking about one of those, a concept that was basically laughed out of the room, called pathological science over 30 years ago, but is now somehow making a comeback.
And what's got this zombie science stirring again? Well, it all starts with this number, $10 million. That's how much the U.S. government's advanced research agency, ARPA-E, the people who fund the really out there, high-risk, high-reward stuff, have just put on the table for this field.
And the field they're funding is called low-energy nuclear reactions, or LNR for short. In plain English, ARPA-E wants to finally get a definitive answer on whether this could be the key to a completely new carbon-free source of energy.
Okay, but hang on a second. Low-energy nuclear reactions. If that sounds kind of familiar, almost like a code word, you're not wrong. Isn't that just a fancy, scientifically sounding rebrand of one of the biggest scientific controversies ever, cold fusion?
Yep. And to really get why this new funding is so shocking, we have to jump in the time machine and go all the way back to 1989, back to a revolutionary promise that went down in flames.
The original claim was, honestly, almost too good to be true. Two respected chemists, Martin Fleischmann and Stanley Pons, held a press conference and said they'd done the impossible. They claimed they'd achieved nuclear fusion, literally the power of the sun, in a simple glass jar on their lab bench. The promise was nothing short of limitless, clean energy for the entire planet.
And for a minute there, the world went nuts. But science is a tough business. Labs all over the globe dropped everything to try and replicate it, but most of them couldn't. The results were all over the place, and just as fast as it started, the dream came crashing down. By the end of the year, a Department of Energy panel said there was no convincing evidence. By 1990, cold fusion was officially dead. It was a mistake, a hoax, a cautionary tale.
But here's where the story gets really interesting. The research, it never actually stopped. It just went into exile. It went underground, far away from the scientific mainstream.
The first thing they had to do was a strategic rebrand. The name cold fusion was toxic. It was a career killer. So they started calling it low-energy nuclear reactions, or LNR. It's a much more neutral, boring, scientific-sounding name, and it allowed a small, dedicated community to keep working without all the drama.
And boy, did they keep working. For the next 3 decades, these researchers, often with almost no money, quietly kept at it. They published hundreds of papers, mostly in journals you've never heard of, building this body of work that was almost completely invisible to the rest of the scientific world. And the things they were claiming to find were pretty wild. It wasn't just excess heat, getting more energy out of the experiment than you put in. They were reporting the telltale signs of real nuclear reactions, things like neutrons, tritium, and even transmutation, where one element somehow magically turns into another inside the device, stuff that just shouldn't be happening. So, you might be asking, if they have all this evidence, why did nobody believe them? Well, it all comes down to one massive critical flaw: repeatability. You could run an experiment and get an amazing result one day, and then do the exact same thing 10 more times and get absolutely nothing. Without being able to make it happen on demand, you don't really have science. You just have a collection of weird, unexplained anomalies.
Which brings us right back to today. Why is a super serious, no-nonsense agency like ARPA-E suddenly willing to dive into this complicated, controversial mess?
Well, ARPA-E basically diagnosed the problem perfectly. They saw a field trapped in a classic catch-22. The researchers couldn't get the serious funding they needed to buy the high-tech equipment that might give them definitive proof because they didn't have definitive proof. It was a vicious cycle, and someone had to be the one to break it. ARPA-E decided to be that someone.
But they're not just throwing money at the same old stuff. No way. They're demanding a totally new, much more rigorous approach. They're saying, forget just trying to get lucky. We want you to test specific, clear hypotheses. We want multiple, sophisticated sensors all measuring the same thing at the same time, and you have to bring in experts from other fields and promise to publish everything, the successes and the failures, in top-tier journals.
And you can already see this new approach in action. In places like the University of British Columbia, their Thunderbird reactor is a world away from that simple glass jar from 1989. We're talking about a particle accelerator hooked up to an electrochemical cell. It's a highly sophisticated machine designed to get real answers.
So, after 3 decades wandering in the scientific wilderness, this whole field is finally getting a second chance, a shot at redemption. But what's really at stake if these researchers are finally able to prove they were onto something?
Well, the potential upside is just astronomical. ARPA-E's own documents say that if LNR is proven real and can be scaled up, it could be a massively disruptive technology for pretty much everything: industrial heat, transportation, defense, space, and of course, a new source of carbon-free energy. It's a huge long shot, for sure, but the payoff could literally change the world.
And that leaves us with this one final, kind of uncomfortable question. For 30 years, the scientific consensus was absolute. Cold fusion was a dead end. Case closed. But what if that certainty was premature? In the rush to shut down a messy, inconvenient result, did the scientific community accidentally sideline a technology that could have given us a 30-year head start on solving our energy problems? We don't have the answer, but for the first time in a very long time, it feels like we might actually be about to find out.